Hi guys, in our today's session, we'll be looking into the user space APIs related to time. So let's get started. So question for you now is, what is the command to get the current date and time in Linux? So what is the command to get the current date and time in Linux? So the answer for this is date. So the date is a command which is used to get the current date and time in Linux. So when you're typing date, it will give you the current date and time in Linux. So it also gives you the time zone as well as time and date. So one of the utility which related to time is date. Let's look into the other utilities. So if you want to find out how long your system is up, how much time it has passed when you have switched on your system, you can use the command uptime. So uptime is a command which will tell you how long your system is up. So let's type uptime. It will give you some information. The first information is the time, so which is the same as date. So this is the time. Next it says it is up for like 5 hours and 7 minutes. How many users have been logged in, and then the load average. So let's see what is load average. So load average, it is the average CPU load, which is nothing but average number of jobs in your system's run queue for 1, 5, and 15 minutes. So this is the average CPU load for 1 minute, average CPU load for 5 minutes, average CPU load for 15 minutes. So how can I understand load average? So if your averages are 0.0, this means your system is idle. If the 1 minute average is higher than 5 or 15 minutes, like here, then the load is increasing. If the 1 minute average is lower than 5 or 15-minute averages, then the load is decreasing. Let's see what it is. Here it is lesser than the 5-minute average. So this means the load is decreasing. And if they are higher than your CPU count, so suppose if I have 6 processors and the average load average is more than 6, then you might have a performance problem. So you can check load average and verify whether your load is more than you can check the performance of your system. So using uptime, it gives all the information. It gives how long your system is up. It also gives you the load average. So where is this uptime utility getting its values? From which file it reads and it gives the values. So let's say use trace. So you can see here it is opening a file. Let's grep for open it. So it does not work. It opens a file, proc uptime. It also opens a file, proc load average. So this both files, it takes the values and then it displays it. So let's look into the file proc uptime. So proc uptime, you can see here, this has the values in seconds actually. So let's see what is this values. What does those values signify? So uptime, first value is uptime in seconds. So the first value which is present in the proc uptime is uptime in seconds. The second value is, so here it is 18630. If you divide, this is in seconds, and when you convert it to hours and minutes, this is what you get. Then the next value is total time spent by all processors in idle process. So the second field is time spent by all the processors in idle process. Then next value is, next file is proc load average. So and you can see here first three values are here. So these values are taken from the proc load average. And then we have two more fields. Then the fourth field here is 5 by 684. What is this 5 by 684? So the fourth field is consists of two numbers which we have seen like this, separated by a slash. The first of this is number of currently executing kernel scheduling entities, which can be processes or threads. So the first field is how many are executing currently. In my system, 5 are executing currently. This I can change. Currently running are 5, and then 684 are number of kernel scheduling entities, which means the processes or threads which exist on the system. So this is what is present in this fourth section. And the fifth one is the process PID of the process which is most recently created on the system. So PID of the process which is most recently created on the system. So when I run cat, it creates one more process. That is why PID is frequently being changed. So you can see PID is frequently being changed. So we have seen two utilities. One of them is date, which gives us the time and date of the system. And then we have seen uptime, which gives us how long the system is up. And it also gives us load average. And then we have seen what are the files which uptime uses. It is proc uptime and proc load average, load average. Now, there is one more time we normally use in Unix programming. We call it as epoch time. So epoch time is the number of seconds which have been elapsed since January 1, 1970. So number of seconds that have elapsed since January 1, 1970 to now is called as epoch time. So if I want to find out epoch time or Unix time, I can use date and pass percentage s as an argument to date. So date plus percentile s will give me the epoch time. So let's use it. So this is the epoch time. You can see it is increasing every second. So I can also use a watch tool and I can show you that it increases every second. So watch tool, let's run the command date every second. And then you can see here, it is increasing every second here. So you can see this increases every second. And this is also increasing every second. So epoch time is a number of seconds elapsed since January 1, 1970. Now we know we have a utility through which I can get the epoch time. But if I want the epoch time from my C program, so how can I get the epoch time from my C program? So the API for that is time. So time returns a number of seconds since the epoch. So, and it accepts an argument. If you pass a null, no issues. But if you do not pass a null, if you pass a non-null value, then the value of the epoch time is stored in this particular pointer. On success, the value of time in seconds is returned. So it returns the epoch time. If you also pass a non-null value, the value is also stored here. So the difference is it is returning time underscore t. Here you have pointer. So man, so we time. So it is not 1, 2 time. So time, it is a system call. It returns a number of seconds since the epoch. So let's use a sample example and then see that. So I'm passing a null as an parameter to it. So it returns the epoch time. I'm using %LD. Then I'm going for a sleep of 5 seconds. And then I'm again calling time of null. And then we can verify whether 5 seconds have been elapsed or not in the value which is being read from the time system call. So you can see here, Difference is 5. So we can also use again date percentile s, sorry, small s, to get the value. We can compare it. It was 322 and 324. So we are able to get the epoch time from our C program using time system call. So if you have epoch time, now if you want a string representation of the epoch time, or if you want it to be displayed in hours, minutes, seconds, and all, you can use C time. So C time, it accepts time underscore t as an argument, and it returns a string representation of the time. The header file which you need to use is, which has a prototype, is time.h. So let's see this example here. So now in this example, I'm passing non-null value here. So I pass a pointer of time underscore t. So I get the epoch time. I want to display it in string. I want to get a string representation, which is a human readable representation. So C time will give us that. So man C time, it's 3. So this is a library call. So you can see it gives a very human readable format similar to what here you have seen. What date command gives the same thing. So we are able to get a human readable format also in our C program using C time. Then we have one more API, which is get time of day. It returns the current wall, clock time, and time zone. The header file for this is system.h, and accepts it has two parameters. One is stuck time val, other is stuck time zone. So stuck time val, it gives number of seconds and microseconds in epoch. So time, it only gives us the resolution of seconds. But if I want resolution in microseconds, I can use get time of day. So in time, you can see it only gives us time underscore t, whereas get time of day, it passes the value in time val structure. It has a resolution of microseconds. And then we have tz as a time zone structure. But from Manpage, what we have read is the use of time zone is absolute. It should be specified normally as null. So we'll normally concentrate on here because Manpage says that this is absolute and it should not be filled. You should pass a null pointer here. So get time of day, difference between time and get time of day is time, it gives the precision is in seconds, and get time of day, the precision is in microseconds. Both gives us number of seconds since the epoch. So let's use an example to understand. So I have a structure. I have included the header file system.h, struct time val. I get the time val using get time of day. I pass the address of this particular structure. Then I get number of milliseconds. So we know that get time of day gives in precision is milliseconds, not milliseconds, it's microseconds. But I convert the whole into milliseconds. So I multiply 1000 with seconds and I divide 1000 with microseconds. So now I have number of milliseconds since the epoch time. And I print it in local string representation, human readable format. I print both number of seconds since epoch time and number of milliseconds since epoch time. So you can also have milliseconds because I can divide microseconds by 1000 and I get millisecond resolution. So if you need millisecond resolution or microsecond resolution, you can use get time of day. So again, let's verify get time of day. It is a system call. You also have set time of day. command page here, you can see here, the use of time zone structure is absolute and should be specified as null. So it gave us number of milliseconds since epoch time. So we have seen two APIs to get the epoch time. One is time, the other one is get time of day. So question is for you, can I use get time of day to determine elapsed time? So can I use get time of day to measure the time between two particular instances? So we know get time of day, it gives us number of seconds which have been elapsed. So I take two, for example, I can take two variables. One, I can use it to store it before executing a particular section. And after I execute, I again call get time of day. And again, I store it in the second value. And then I subtract it. So I will get the elapsed time. So can I use it? So let's see whether we can use it or not. So let's see a sample example here. So I take two structure, time val, start and end. So before executing my particular logic, I call get time of day. And after executing my logic, I call get time of day. I store it in start and store it end. So get char I'm using here to measure just for an demonstration. But here it can have any of your function which you want to measure the number of elapsed time. So if you want to measure the elapsed time, you can have any function which you have. For our demo, we are using get char. So we wait until user presses an enter or something. So now again I can subtract here seconds and microseconds. So this can go negative because we have seconds can, so this can go negative. So you have to have your own logic here. So for now we keep it simple. So and we display the seconds, elapsed seconds and elapsed microseconds. So let's run this. So it has first stored the time, pause time in start. Now it is waiting for user input. And now you can say it gives us the elapsed time is 11 seconds. And minus is because of the microseconds. So you can write your own subtract function for this. Okay, let's leave about this. So it gives us elapsed time is 11 seconds. So this means we can use get time of day for measuring the elapsed time. Is there any tweak here? So suppose I have started my program. So it took the epoch time. But if I modify the date, what happens? What happens if I modify the date? So instead of keeping the date to, if I modify the date 1 hour backwards, what will be the value now? What will be the output? So how can I modify the date? Let's see first. So the command for modifying is, let's take the command from here, bracket for date. So to change the date 1 hour backwards, I can use this particular command, sudo date -- set -1 hour. So the current date is this. So if I want to set it to 1 hour back, I can use that particular command, but I have to be a super user. So it has, you can see it prints that particular date. Now let's verify the current date, run date command, but the date is back to the original date. So why it is not updating? Let's try it again. So it has set it back to 1 hour, but when I run the date command, it is showing the current, not modified date, unmodified date. Why is it so? Let's do it one more time. It's not working. So is there any other issue here? So issue here is there is something known as NTP, Network Time Protocol, which is what it does is it will try to set the exact time querying the network. So NTP protocol is running on background. It sees the time is not matching the exact network time, and then it updates the time. So for our example, let's stop the NTP service. So there's a service which runs in background, which does all this. For this particular example, let's stop the service. Let's stop the service for this. So how can I stop it? So this to stop this NTP service, this is the command. So we are using systemd, so it is specific to systemd. So systemd time sync d is a service. Let's stop this NTP service now. Now let's modify the time. And now again check it back. Now you can see time has not updated. It has the time which we have told it. So we have said it like set the time 1 hour back, and the time is the same thing. It has not updated its time to the network time. So now let's do an enter here. So get char is still waiting for an input. Let's give an input to it. And you can see here, it gives us -3426 seconds, which is a wrong out elapsed time. It should not be a negative seconds, right? Elapsed time should be always positive seconds. So this is because we have modified the time. That's the reason you get here a negative elapsed time. So let's start it back, the NTP service. So to start it back, you use start. So we can verify the date. It's the exact date and time as per the network. So what we have seen here till now is using get time of day, you cannot measure the elapsed time. So if your program needs to measure the elapsed time, you need a timer which will give you the right answer even if the user changes the time on the system clock. So you need a timer which will give you the right answer even if the user changes the time on the system clock. So do we have such clock in Linux? Let's look. So the familiar system clock which tells the time of day, we call it as real-time clock or wall clock. So the wall clock or real-time clock is a time which is a clock which tells the time of day. So till now when we were using real-time clock or a wall clock. But if you want to measure elapsed time safely, you need a clock which ticks out time continuously without any jumps when a user sets the system time. So this kind of clock we call as monotonic clock. So now we have two kinds of clock, real-time clock, and the second one is monotonic clock, which will not be affected when the user sets the time, system time. So if I want to use the monotonic clock, the API is different. This clock underscore get time. So this particular API or function, it can be used to retrieve the time from various clocks. It can also use to include, this can include the real-time clock, also the monotonic clock. So the first argument tells which clock from which I have to read. And the second is where the value of the time is present. So it uses a different structure now, time spec. Till now we have get time of day, it used struct time val. But clock underscore get time, it uses a different structure, struct time spec. So the difference is it is higher precision. Struct time val, it has a precision of microseconds, but here struct time spec, you can see it has a precision of nanoseconds. And this particular function, which has a first parameter of clock ID, is used to request specific clocks. So these are the differences between clock underscore get time versus get time of day. For monotonic clock, you have to pass clock underscore monotonic as an argument. So let's verify whether this is a system call or a library call. Use man, and this is a system call. So let's again run an example and then we can see what happens. So the same example which previously we used get time of day. Now let's use this clock underscore get time. Clock underscore get time use instead of time value, you'll be using struct time spec. The first parameter is clock underscore monotonic. You have start, you have end, and the same thing get char is there. So the same program, instead of using get time of day, we use clock underscore get time, which is better. It has different kinds of clocks, and we are using monotonic clock. It also has a precision of nanoseconds. So again, we have here nanoseconds. So let's now do the same operation. Let's run this program, user program, the default case. So it has measured, it is like 3 seconds and this many nanoseconds. Now give us the, now let's try to update the date and time. Let's set it back 1 hour back. So for that we have to stop the NTP service, and now we set it back to 1 hour. Now press enter, and now you can see this time it gives us the perfect time, the amount of time which took for in between the get char, the first clock underscore get time and the second clock underscore get time. So using clock underscore monotonic or monotonic clock, you can measure the elapsed time. So you cannot measure the elapsed time using wall clock, because user can change the time at any time. So you have to use a special clock which is known as a monotonic clock, using which you can measure the elapsed time. So let's start our time back.